Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting topic in computer organization and architecture. We're going to start with unit 3. We're going to start with design of ALU. In this unit, you will study very interesting topics like the design of ALU and what are the important components in ALU. We will see about different adders. We will see about half adder, full adder, ripple carry adders, and how to design ripple carry adders, carry local head adders, and we'll see about multipliers and devices. It is a very important and very easiest unit. If you understand the logic of each and every operation, you can write it by yourself. Okay, and this unit is problematic. Okay, even if you have a theory related concepts, each and every concept is related to problems. Right. So, for example, if you study about multiplier, you will study how multiplication takes place, and then you will study about how to implement the multiplier circuit. So, you have to study theory and understand the logic behind it so that you can solve any problems. Right. And today we're going to see very easiest topic. We're going to start with Boolean algebra. We're going to see what are the basic laws that is in Boolean algebra. Right. So we'll start with what is Boolean algebra, why it is important here. Okay, for a design of ALU, Boolean algebra is very important for designing logic gates, logic gate calculation and all those things. Okay, and only if you understand the Boolean operation, you can able to solve complex equations, that is implementation of gates and all those things. Okay, and for introduction of Boolean algebra, you got to know what is variables. Right. So variables is a symbol which represent an logical quantity. Right. So it can be of 0 or 1. Right. So any numbers, any value, that is A, B, everything is represented as variables in systems. Correct. Right. So any variable will have only two values, either 1 or 0. Right. And what is complement? Complement is the opposite of variable. For example, if you say A is a variable, okay, if A is a variable and if A is equal to 1 and the complement of A is 0, right? And similarly, if B is equal to 0, right, if you say variable B is equal to 0, then B complement is equal to 1. That is the opposite of A, the opposite of the variable. Okay, and this complement can also be called as, like, it can be called as complement, or that is A complement, or we can also call it as A bar. Similarly, you can call it as B complement, or it can be called as B bar. Okay, and literal is a common term which is used in Boolean algebra. Okay, so literal is nothing but it defines both variable and component. Okay, and the very basic Boolean algebraic equations are Boolean addition and Boolean multiplication. Okay, and this Boolean addition and Boolean multiplication is very similar to your logic gate, that is OR gate and AND gate, right? And that is why most of the equations is very important to simplify the logic gates. All the Boolean algebra equations is very important to understand or to design a sequential circuits. Okay, so if you can able to understand the rules and regulation of Boolean algebra, you can able to implement for any sequential circuit designs. Okay, so first we'll see, we already know what is OR operation and what is AND operation, right? And which is very similar, that is Boolean addition is very similar to OR operation and Boolean multiplication is very similar to AND operation, right? And we will see about laws of Boolean algebra, very basic laws, very basic laws. Okay, and you can see that the OR gate, right? Boolean addition, I said that Boolean addition is all about the OR gate operation. Okay, and I'll refresh the OR gate operation. The OR gate operation is, this is the OR gate symbol, right, where you have two inputs A and B, right, and it can be represented A plus B, correct, right? And the truth table of it, right? 0 0 0 1 1 0 1 1 is the input. If it is 0 0, then it is 0. It is like a normal addition, right? 0 1 is 1 and 1 0 is 1, and 1 1 it's 1. This is the only one you got to understand. 1 1 is 1. Okay, and you got to understand that in binary addition, you will represent 1 plus 1 is equal to 1 0, right? But in Boolean and as well as in OR gate, it is represented as 1 plus 1 is equal to 1. Okay, from this truth table, you can understand that these are the literals, right? These are the literals, right? A and B, these are the literals, right? Whenever, if there is even one literal is 1, right? That is, even if it is one literal, if it is A or B, even if it is one literal is 1, right? Then the output will be 1, correct? Right? That is, the output of the OR gate is high if any one of the input is high, correct? ஏதாவது ஒரு input வந்து ஹையா இருந்தாவே output வந்து ஹையா இருக்கும், right? And similarly, you know that if both the inputs are 0, the output is low, right? And I already explained the gate timing diagram as well, right? That is 0 0 can be represented like this and 1 1 represented like this, right? And once again, that is A, you can see here 0 0 1 1, right? So it is 0 0 1 1, correct? And next one is 0 1, that is 0 1 0 1, right? And the output is represented as 0 and 1 1 1, correct? So this is the basic OR gate operation, which is very similar to the Boolean addition, right? Similarly, the AND operation, that is Boolean multiplication. I said that Boolean multiplication is very similar to the AND gate operation, right? The AND gate operation is, you know that it is a normal multiplication, right? So it is 0 0 0 1 1 0 1 1 is the input, right? So if you multiply this, you'll get 0, right? 0 0 and 1, which means you can understand that if any one of the literal is 0, right? If any one of the literal is 0, then the output will be 0, right? Only if both the literals are 1, you will get the output as 1, correct? That is the AND gate operation, right? That is what it represented here. That is the output of AND gate is high if its inputs are high. If both the inputs are high, right? If any one of the input is low, then the output will be low because it is a multiplication, correct? So this is the symbol of AND gate. Okay, this is for two inputs, and if it has multiple inputs, you can represent like this, right? That is 2n. Similarly, for 2 input OR gate, this is right, and for n inputs, you can write this. You can represent like this. Okay. Now you understand what is the relationship between AND gate, OR gate, and as well as the Boolean addition and Boolean multiplication, correct? Right. And now we will see about the basic laws of Boolean algebra. Okay. So Boolean algebra, you already studied all these laws, right? Even in your 8th or 9th standard. This is very, very simple rules and regulations. Okay. So Boolean algebra laws, the very basic laws is commutative law and associative law and distributive law, right? And in commutative law, you'll have laws of addition and laws of multiplication. Similarly, in associative law, you have laws of addition and laws of multiplication, right? And there is a common distributive law, right? So this is very simple. I'll just tell you what is the rule and then how to implement that using gates, okay? So first one is commutative law, right? Commutative law of addition, right? And from this particular expression, you can understand A plus B is equal to B plus A, right? So what is the logic behind this particular law, right? The logic behind this law is, the law says that even if the order of the variable is changed, you know that A is a variable, B is a variable. Even if the order of the variable is changed, right, the output will remain the same. That is, even if it is A plus B or B plus A, the output will be same. This is the logic behind this commutative law of addition. Okay, and you can see how technically this is expressed, right? The law says that the order in which the variables are on make no difference, right? That is, even if it is A plus B or B plus A, in any order, it will be the same, right? And how will you represent using gates? You know that A plus B can be represented like this, right? A plus B, right? And this is similar to B plus A, right? So according to commutative law of addition, it's A plus B is equal to B plus A, right? And this is the logic gate implementation, right? And similarly, commutative law of multiplication, same rule, but it is for multiplication, right? Even though if the order of the variable is changed, the output will remain same, right? Even in multiplication, right? For example, you can understand that 0 into 1 is equal to 1 into 0, correct? Right. Similarly, 1 into 1 is equal to 1 into 1, right? It doesn't matter the variable order is changed or not. Okay, the output will remain same, and that is what it is mentioned here. The order in which the variables are AND make no difference. Okay, so now we got to represent using AND gate, right? So it is A into B and then B into A, right? That is equivalent to BA. AB is equal to BA. Okay, this is commutative law of multiplication, right? And next one is you'll see associative law of addition. This is a little advanced than commutative law, right? So what is associative law? You can see this expression. First, I'll tell you the meaning of it, right? What is the associative law of addition? That is, right, irrespective of grouping, right? Regardless of grouping, the output will remain same, right? It doesn't matter in which variables are grouped, unless and until it is the same operation, the output will be same, right? You can see here it is A ORed with B plus C, right? And similarly here A plus B, that is ORed with C. That is, here first we have to add B plus C, and then we will add with A. Similarly here what you are doing, you are going to add A plus B and then you will add the answer with the C, right? Both are equal, right? So according to associative law, it doesn't matter wherever, however you group the variables, right? Unless or until if it is the same operation, if it is AND operation, it has to be same. If it is OR operation, it has to be same, right? Then the output will be same, right? You can see here, the law states that ORing more than two variables, the result is same regardless of grouping the variables, okay? And you know how to implement this using gates. B plus C, it is represented in OR gate, right? B plus C, and then that particular output is given here, and the input, that is A plus B plus C, this equation. Similarly, that is equivalent to A plus B, that is first expression, A plus B, and then that is ORed with C, correct? So this is associative law of addition. Similarly, this is applicable to associative law of multiplication, right? You can see here, irrespective of grouping, right? So the output will be same. You can see here, A into B into C, that is equal to AB into C. The same expression, but here we are using multiplication. Okay, that is, there is no difference in what order the variables are grouped when ANDing more than two variables. Okay, now how will you represent here? So you have to represent B into C, that is using AND gate, right? And then A into B into C, there is another AND gate, two AND gate. Similarly, for this one AND gate, AB, and then the output is AND with C, right? So this is associative law of multiplication. Okay. So the third law is distributive law, right? So distributive law can be written like this way. You can see that distributive law, it combines both addition and multiplication. Okay. And the thumb rule here is you have to understand, right? You will use three variables. One variable, that is two variables, is used in OR operation, and one variable is used in AND operation. Okay, and if you're going to do this, then that will be equivalent to, right, what is the variable which is used here, right? It will be the product of both these variables. Okay, that is AB plus BC. That is the distributive law. You can see here, ORing two or more variables and then ANDing the result with a single variable is equivalent to ANDing single variable of each of these two variables. Okay, right? So that is called as distributive law, right? And in order to express this distributive law, right, you can see here, this can be represented as like AB plus BC. You can take A as common, right? And you can write as B plus C, correct? Right? So this is equal. Both the things are equal. Okay. Now, how will you implement using gates, right? You can see here, first what you have to do, B plus C. I take this one, right? B plus C. How will you represent B plus C? By using a OR operation, right? And then what you will do? You will do A into B plus C, correct? A into B plus C. So now this OR operation and then A is ANDed here. That is the X, right? And that is equal to what we said, AB plus AC. So what you have? You have two AND operation, right? So AB is one AND operation and AC is another AND operation, and you have to OR, that is you have to OR this two operation, that is you have to add AB plus AC, that is this expression. Okay, so this is the distributive law, which is nothing but A into B plus C is equivalent to AB plus AC. Right? Right? You got it? Right. So what we have seen so far is today we have seen very important concept in Unit 3. We have seen basics of Boolean algebra. Right? We have seen what is variable, what is complement, and what are the different laws of Boolean algebra. Right? We have seen what is associative law, what is commutative law, and what is distributive law. Right? In commutative law and associative law, you have law of addition and law of multiplication. Right? And this is very simple concept. Hope you're clear with that, right? Thank you, students.
Thank you, students. Thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும்னு நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.